Hi everyone, today we're going to talk about how to solve two-step equations. Now this is going to be really weird, but when you're solving two-step equations, I want you to think about taking off your shoes and socks. So we're going to go through the steps of taking off your shoes and socks. Step one, of course, is to find your foot. There it is underneath the socks and the shoes that you put on. Now you do have to kind of think back and think to yourself, well, if I'm taking off my shoes and socks, I kind of have to think back at what I did when I was putting on my shoes and socks. Well, first I put on my socks and then I put my shoes over it. So if I'm now going to take off my shoes and socks, I have to go in reverse order. I'm not going to be able to take off my socks first, even though that was the first thing I did, right? Because my shoes are covering them. So since my shoes were put on last, I'm going to go in reverse order and I'm going to take them off first. So if step one was to put on my socks and step two was to put on my shoes, then I'm going to reverse that and I'm going to take off my socks first and then take off my shoes first and then take off my socks, going in reverse order. So if you notice, my operations are going in reverse. Instead of putting on, I'm now taking off, and the order is going in reverse as well. So we're going in reverse order, the inverse operations. You're undoing the operations. So if you remember, when you undo operations in math, it's called inverse operations. Go ahead and pause the video and jot that down into your notebook. You don't have to draw the entire diagram there. You can just be like putting on socks and then putting on shoes. So then undoing it would be taking off socks first and then taking off shoes and then taking off socks. I'm getting it all mixed up in my head. And remember that you are reversing not only the order, but you're reversing the operations. All right, so now what does this all have to do with solving two-step equations? So if you can remember back when we were solving normal problems that had numbers, for instance, 28 divided by 4 plus 2, you'll remember that you have to follow PEMDAS, right? You have to solve parentheses, then exponents, multiplication or division, whichever came first, and then adding or subtracting, whichever comes first, left to right. You have to follow that order. So here I don't have parentheses, don't have exponents. I do have a division. 28 divided by 4 is 7. And then bring down that 2 over here, which I didn't touch. And then last, adding or subtracting left to right. So that's 7 plus 2, which is 9. Solving a normal problem with numbers, you're following PEMDAS. Well, now this is new right here. If we're solving a problem with unknown variables, where we have an x or a y, just a variable there that we want to figure out the answer to, we're going to do the reverse. We're going to simply reverse that. By reversing that, we're going to reverse the order and we're going to reverse the operations. So now we are following SAD-MEP. So this right here should go into your notebook, a SAD-MEP. I don't know what a MEP looks like, but it's sad. And it's not going to be happy until we solve for that unknown variable. Very easy to remember, just the opposite of PEMDAS. Okay, let's go through and solve an example problem. And I will keep SAD-MEP up there so that you remember. So pause the video, try this problem out. 2x plus 3 equals 9. Try to solve for x using SAD-MEP. So show your inverse operations. Okay, I'm going to first draw a line here because I see an equal sign. So that means I'm really working with a balance. I want to keep the left side equal to the right side. I want to do the same thing on both sides. and I'm going to follow SADMAP. So according to SADMAP, I'm going to subtract or add whichever one I see first, going left to right, and I see it a +3. Now remember, if I see a +3, I'm going to do the opposite. So if I see addition, I'm going to do subtraction. If I see subtraction, I'm going to actually perform addition. So I see add 3, so that means I'm going to subtract 3 on both sides in order to keep that equal. 3 minus 3 cancels out, so I'm left with just 2x on the side, equals 9 minus 3 is 6. Okay, next up, divide or multiply, whichever one I see first. Well, I see multiplication, so the inverse operation is division. If this is being multiplied by 2, 2 times x, I'm going to do the opposite, which is divide by 2. 2 divided by 2 is 1, so I end up with 1x, which is still x, equals 6 divided by 2 is 3. So I get the answer x equals 3. And I'm done. Now, let me see, before I actually put that check there, let me actually check and see if my work is correct. How do I do that? Well, I'm going to copy the problem back down. And instead of x, I'm going to put down 3. So instead of 2 times x, I'm going to substitute in 3 and see if that works. 2 times 3. Okay, so now I have all my numbers. And so now I'm going to use PEMDAS because I have all my numbers. PEMDAS says I have to multiply and divide first. So here's multiplication. That's 6 plus 3. And then I have adding or subtracting. 6 plus 3 is 9. Does 9 equal to 9? Yes. So if I get a true statement at the end, then I know I'm correct and I got the correct answer. So to review, we used SADMAP when we didn't have the answer. We're trying to find the unknown variable. And then when we're checking, we're going and doing it back in reverse, or I guess the right way, to check. So we're basically doing and undoing, and it should get us back and forth back to the same answer. Okay, now let's just do a quick review of what it would look like if we were using a balance. So this is that same problem. 2x plus 3 equals 9. I got 2 x's on one side plus 3 blocks equals on the right side to 9 blocks. 2x plus 3. In order to figure out what one of the x blocks is equal to, I'm going to have to move some stuff around. So I want x by itself. Well, I first got to get rid of 3 of these blocks on the left-hand side, but that means my right-hand side is too heavy. So I got to also subtract 3 blocks from the right-hand side to even it out, keep it equal. Okay, that's what we did. We subtracted 3 from both sides when we were solving it algebraically. So first we subtracted 3 from both sides. They showed it right there. And then we have just 2 x blocks left, and we have 6 blocks left over on the right-hand side. I want to figure out how much one x block is equal to. So we're going to divide it into 2 groups of x's. And then we're going to also divide these 6 leftover blocks into 2 groups as well. So that now we know 1x box is the same weight as 3 these green boxes. So that 2 of the x blocks or boxes would equal to 6 blocks on the other side, or also x equals 3. So they divided by 2. So that's if you were to actually put stuff onto a scale and act it out. So algebra is a great shortcut. Instead of getting out a scale and taking out some blocks and actually taking things on and off and dividing and all that, we just need, I don't know, a minute and paper and pencil, and we got there the same way. Inverse operations. Okay, we're going to do one last example problem, example 2. So this problem says 3 equals f divided by 6, or f over 6, minus 1. Go ahead and pause the video. Try it on your own first using SADMEP. Okay, so like I said, we're going to use SADMEP. We know we have to use SADMEP because we're sad. We don't know what that f stands for. We don't know that variable. So we're going to go in reverse order of PEMDAS. SADMEP says we got to add or subtract first. I see a subtraction, so remember it's in reverse. I got to do the opposite, the inverse operation. So even though I see minus 1, I'm going to do plus 1. Because the whole point is we want to get f by itself. When I have minus 1 and plus 1, they cancel each other out because they're opposites of each other. So now I have just f divided by 6 on the right-hand side. And then on the left-hand side, I have 4. We did the same thing on both sides so that we could keep this equation equal and balanced. We did the opposite operation because according to SADMEP, we got to do opposite operation in the reverse order. That canceled out the minus 1. So now we have 4 equals f divided by 6. So next we do division or multiplication. We see division here, divide by 6. So then the opposite would be to multiply by 6. Both sides. Okay? Now with multiplying by 6, this looks really confusing, right? Sometimes people will take this and then multiply it and get it to 36. So that would be wrong. This 6, I want to put it over 1 so that I can see that this 6 is the numerator and not the denominator. So f over 6 times 6 over 1 would be 6f over 6. So then you would see that the 6's on top and bottom cancel out. 6 divided by 6 is 1. So you end up with 1f. Okay, so when you have a fraction, you want to multiply the other one as a numerator so that you can see they cancel out this way. They don't become 36 because one's on top and one's on the bottom. So sometimes people will write it on the side so that they can work it out that one's on the top and one's on the bottom. It does not equal to 36 because one's on the top, one's on the bottom. And that leaves us with f on the right-hand side, 1f, but I'm just going to put f. 6 times 4 is 24. So my answer is f equals 24. Now again, let's say I'm not really sure if that's correct. There's a fraction in the problem. I'm taking a test and I just want to double check. You can do that on the side. Remember, you solved the problem by using SADMEP, so you're going to check the problem by using PEMDAS. Okay, so I'm just going to rewrite the problem. And instead of f, I'm going to put in 24 because that's the answer that I got over here. And I'm using PEMDAS, no parentheses, no exponents, multiply or divide first. 24 divided by 6 has to be solved first. 24 divided by 6 is 4. And then at the end, I'm solving my adding or subtracting. 4 minus 1 is equal to 3. 3 does equal to the 3 that we wanted. So that is correct. That is a true statement. So therefore, I know my answer, f equals 24, is also correct. Now, let's say I didn't get 3 at the end. I got 5 or something. Then that would mean that my answer was incorrect and I got to go back and see if I had any silly errors.